Okay. Okay, perfect. So for the time being, I am happy with where we're at with front end. We covered HTML, we covered CSS, we covered JavaScript very much in depth, especially as it relates to what's happening within the browser. And so now we're going to pivot to look at the back end. And if you look at my tentative set of lectures that are remaining, I anticipate to jump back to the front end to cover React after we have a little exposure of how we can use Node to develop a web server. So this next lab that's going to be assigned tomorrow will essentially be one that will be implemented in the Node environment and no longer the browser environment. So we'll pivot away from the browser for just a little bit. We'll have to obviously return back to it to test some things out as we develop web servers. We will need web clients or something like Postman or curl to be able to test our endpoints. But we're definitely going to be pivoting now with a predominant focus on web servers and web server design. And let's see here. So let's see. So if you're working in a group for the project and only one abstract needs to be submitted, but individually, what do we need to include in our submission? Okay, so that's a good question. Let's talk about submissions. In terms of the proposal itself, the proposal document, everyone who's in a group can turn into Moodle the same document. And so I need a submission on Moodle to be able to give you a grade. However, the first part of the final has one additional component on top of the document. It's also to produce a blog post, essentially announcing that you are working on a full stack application, what the idea is, what the idea for the app is, and who your team members are. And so for me, this acts as kind of a confirmation across all team members that they're working on the same project and they're self-selecting each other as their team. So it just helps allow me to reconfirm what's stated inside of the document. And also it's perfect for you to be able to have that blog post for your portfolio page to begin with. Does that answer your question?
Yeah, it does. Thank you.
Excellent. Okay, so today we're going to start on our first lecture on our backend services. And so it naturally makes sense to cover Node first. So I've created a massive set of slides, and I'll probably not go through all of these because honestly, not all this content is mission critical for delivering on a web application. However, these slides are designed to have a dual purpose. It's not only to allow me to guide a conversation and lecture on each of these domains, but to serve as a reference point for you. So I made this particular set of slides a little bit more verbose so that you can reference it later on as you continue your journey in is a backend developer using JavaScript. So you kind of key in on more and more of the underlying details. So this is a, let's see here. It's a, let's take a look at the overview. So for instance, some of the stuff you will not care about because you'll rely on external modules to take care of it, in particular streams and buffers. And so I won't go into great detail, but I do have lots of examples in here. So if you were interested, if you were so inclined to see how Node handles some of the typical concerns that a programming language might have, you can go ahead and see how it's handled. But again, a lot. Once we hit Express will allow us to automate a lot of these, a lot of this without having to worry about implementing it by hand. Anyway, so today's lecture, I kind of want to cover what is Node, an introduction, and then how do we interface with Node at the command line. So this will allow us a JavaScript runtime environment that's removed from the browser. So we can interface with it the same way. We can interface, say, for instance, with the Java Developer Kit or with Python or any other language that you might be able to from Bash terminal. We'll look at the REPL console. We'll look at how we can then go ahead and issue console out and console input into source code files or JavaScript files. We'll look at how modules are handled in Node as it relates to the browser. We'll look at the event loop and an event emitter. We'll look at asynchronous JavaScript on the server side, and then we'll talk a little bit about streams and buffers and error handling. So by the end of today's lecture, we'll have covered essentially the basics of Node itself. And when I say Node itself, what I really mean is the runtime environment that we can go ahead and get on JavaScript available essentially at the OS level. So essentially, we're going to be comparing this a lot to browsers because that's the runtime environment we've become quite familiar with. Okay, so jumping into the intro. So what is Node? Node is an open source cross-platform JavaScript runtime environment. Yep, so it allows us to run JavaScript code. It's popular for developing server-side and networking applications. That popularity translates into a lot of libraries and modules that are provided to us right out the box to make building web servers extraordinarily easy. And that's one reason why Node has become so popular. Node.js, that's typically what it's referred to, Node.js, is applications are written in JavaScript, and it allows us to run JavaScript applications on essentially all the major OSs, so OS X or Mac OS, I think is how it's kind of been rebranded, Microsoft Windows and Linux. So a little bit more details. Node.js runs the V8 JavaScript engine. So that is actually the core of Google Chrome, but it runs it outside the browser. Again, allowing JavaScript now to serve as a general purpose coding language. So up to this point, you were only really able to execute your JavaScript codes inside of the browser. And so this is what really allowed us to pivot into using JavaScript in very new and interesting ways. So Node.js uses an event-driven, non-blocking I/O model, which makes it lightweight and pretty efficient. So that's one reason why I want to cover those concepts from the browser side of things, because these are very key concepts on how Node is implemented to go ahead and execute our code. And so we'll cover that a little bit more detail, just so you kind of have an idea of how Node is going to execute your JavaScript instructions. So Node also provides a rich library of various JavaScript modules, again, which simplifies web applications. So that's one big use case of Node. It is to build web servers or anything that is networked, any kind of networked application. So again, when you hear Node, what you want to think of is a runtime environment plus JavaScript libraries. Just like when we think of what's happening inside of a browser on the client side, we want to think of that as a JavaScript runtime environment and essentially the browser object model and document object model. And that's really what's going to separate Node from what we've learned with the browser, is what are the standard libraries that are provided to us? What are the permissions that are provided to us? Like, for instance, a lot of you with this new lab have seen that there are security concerns with opening up anything that's cross-origin inside of a browser. And it's because a browser is designed to be a sandboxed garden that is kind of separated away, isolated away from the rest of your operating system. And they do that for security reasons. I mean, one reason why the browser has become the dominant application for front-end networked software is because it was designed from the ground up with security in mind. So the security concerns can be kind of defaulted to the browser when building web applications. And so that's why you can't open up, say, for instance, TCP/IP sockets directly in the browser. You have to use web sockets. Or that's why you can't necessarily trigger certain things or access your local storage very readily inside of a browser. It's for security reasons. Okay. So a Node app is run in a single process without creating a new thread for every request. And so this is what we mean when and so the reason why we can run our code the way we can on a single process is because it's implemented with that asynchronous paradigm. So Node provides a set of asynchronous I/O primitives in its standard library that prevent JavaScript code from blocking, and generally libraries in Node are written with this non-blocking paradigm. So this makes blocking behavior the exception rather than the norm. And so when Node performs an I/O operation like reading from the network or accessing a database or the file system, instead of blocking the thread and wasting CPU cycles waiting, Node will resume the operation when the response comes back. And so pretty much the way these asynchronous operations are happening under the hood with Node is exactly the way it's being handled in the browser. Same metaphor. I mean, there's something to be said that Node is using V8, the JavaScript runtime environment, the exact same runtime environment that Chrome uses, which, by the way, is why I use Chrome for our front-end testing. That way we're using technically the same JavaScript runtime environment on both ends. Okay, so this allows Node to handle thousands of concurrent connections with a single server without introducing the burden of managing thread concurrency, which could be a significant source of bugs. Okay, let's talk about features with Node. So Node, it has asynchronous and it is event-driven. So all APIs of Node library are asynchronous. That is, they're non-blocking. It essentially means a Node-based server never waits for an API to return data. The server moves to a next API after calling it, and a notification mechanism of events of Node helps the server to get a response from the previous API call. So again, think very much in line with the way that promises work inside the browser. We'll go more into detail today inside this kind of run through on how Node works. So Node is very fast. It's built on Google's V8 JavaScript engine, and the Node library is very fast. And its code execution is actually built in C, C++, and I think, so Node is relatively young. It's 11 years old, but I think it's already on version 12. So they're constantly optimizing the code base for it. Or I say Node, I mean, yeah, Node is on version 12, but they're constantly optimizing the V8 engine as well. It is single-threaded, but it's highly scalable. So Node uses a single-threaded model with event looping. The event mechanism helps the server to respond to a non-blocking way. It makes the server highly scalable as opposed to traditional servers, which create limited threads to handle requests. So Node uses a single-threaded program, and the same program can provide service to a much larger number of requests than traditional servers. And so, and we'll talk more about how that manifests itself when we get into talking about web servers and just basic web server design, which I'll probably hold off to until next lecture. Okay, so no buffering. Node.js applications never buffer any data. These applications simply output the data in chunks. And then the license for Node is under MIT license. So we always like open source software, or at least I do. It's one reason why I always have a grudge against MATLAB. I hate developing code on MATLAB. Okay, that's a non sequitur though. So let's talk about the concepts that are going to drive our introduction to Node. So if this is Node.js, they have all these different things that we could potentially learn about. And if you want to consider yourself a true expert in developing software in Node, you should have an understanding of what each of these pieces are. And we'll kind of touch each one of these elements a little bit as we develop our backend applications. In particular, probably like things like modules and error handling and let's see, callbacks. Some of this you might already be familiar with from browser-side development. Okay, so I think the last part I really want to talk about in terms of my introduction to Node is just the standard libraries and the framework. So Node has a massive has a massive set of standard libraries, and in particular, first-class support is for networking. And when I mean by first-class support, it's something we don't have to install additional packages or modules for to get off the ground running. So part of the standard library is a lot of modules that are designed to build web-based applications. So again, that's one reason why it's been so popular for that use case. Now, in addition to the standard library, there's a number of frameworks and tools that have been produced by the community at large. The ones that we'll likely try to look at over the course of this semester is going to be Express, which provides one of the most simple yet powerful ways to create a web server. Its minimalist approach is unopinionated, focused on the core features of a server, is one reason why it's so popular, because you can kind of expand it to any use case that your application might have. And then Socket.io, which is just a real-time communication engine to build network applications. So I had mentioned this earlier when we were talking about HTTP. One of the limitations of it is that it is a request response mechanism for communicating between a client and server, and one that has to be initialized by the client. It's stateless, and it disconnects after the request response cycle has been completed. Socket.io allows you a duplex connection, a two-way connection, where you can stream data between the client and the server in real time. And so obviously some applications require that kind of connectivity. And if you are designing an application, if you are proposing something that might require that, you would want to look at Socket.io for that purpose. And I'll try to have just a lecture sometime later in the semester where we can just do a crash course on Socket. Okay, so I do want to compare Node to the browser, because at this point, everyone should feel comfortable developing JavaScript inside of Chrome or inside of any browser. So I just want to compare how your skills are going to translate into the Node runtime environment. And so both the browser and Node use JavaScript, and they both use the V8 JavaScript engine. The syntax and most of all the libraries that we learned, one reason why we spent so much time learning that is because we can use all those same principles and concepts for both our front-end application development and our back-end application development. However, there's some distinctions we need to set. So in the browser, most common tasks include interacting with the DOM, right? Or other web platform APIs like cookies or local storage or things like that. Those don't exist in Node for obvious reasons. You don't have the document, you don't have the window object. Anything that's part of the browser API is not part of the Node API necessarily. So in the browser, we don't have all so on the flip side, in the browser, we don't have all the APIs that Node might provide. And in particular, the ones that are really nice are the ability to access the file system. So just like you have modules inside of Java or inside of Python that allows you to read and write files, clearly, since Node has OS level privileges, since it's an application that you can access right from your terminal, then you also have these very powerful file system mechanisms. And so you don't get access to those from the browser. And then another difference is that Node uses the common JS module system, while the browser uses the ES module standard. So all this is stating in practice is that when it comes to importing and exporting JavaScript code from one script to another, the syntax is different. They're using two different implementations of a module scheme. So in the browser, and that's one reason why before I got into Node, I wanted to show you how modules are handled in the browser so that you can compare and contrast to how they will be handled inside of the backend, inside of Node. So in the browser, we use the import statement and export statements. In Node, we will use a require statement. They conceptually are doing the same thing. They're importing a function, an object, some piece block of code from another JavaScript file. It's just the syntax is slightly different. And the last comparison was, again, to harp that they're both built on top of this V8 JavaScript engine. So V8 is the name of this engine that Google Chrome put together, yada, yada. So the distinction that we really want to key in is not the runtime environment, it's the supplemental standard libraries and APIs that are built on top of it. And so that's really going to be our separation between our browser and our Node.js. Yeah, I could see that. Node, I could see why it would be easier to use Node.js because you're not faced with the limitations that a browser imposes on you. So you are free to update Node as quickly as they release updates. So your runtime environment is not constrained by a vendor who's maintaining based off of what the users are currently being supported. But not just that, there's a lot of restrictions in the browser for safety reasons. Again, just being able to open a file can be a real pain, or having to serve on an HTTP where you could just run your Node app right from the command line. So there is a little bit more overhead in developing on the front end in terms of having your code base exist in that walled garden and kind of figuring out how to do that in a way that the browser allows. And so you don't have those browser considerations when you're creating code in Node. So for those of you who have designed code in Node, or for those of you who haven't, yeah, notice that those students who have say that actually the backend development is easier than the front end development, which we've already done. And in fact, it's going to be more akin to the types of development you've already done in other courses, such as Java, or if you've done any Python programming, similar to Python. So the means in which we can kind of create our code and run it on our system will be very similar. Okay, so with that said, let's talk about starting to interface with Node, at least from the command line. So you have to install Node. Everyone needs to install Node because we're going to use it. So go to nodejs.org's download page, not necessarily right now, but sometime between now and by the time the next lab is due. So I'm going to issue this next lab on tomorrow, so it'll be due next Friday. Anyway, it supports, there are executables for it for all major platforms. Just go and install it. And I'm going to make this slide set available immediately after this lecture, so you can actually just open up the slide set and go to this hyperlink if you want. Okay, so to run a JavaScript program using Node, super simple. You just type in Node and then the name of your JavaScript application, the file name. Again, this should be very similar to the way that you execute your Java code. So instead of Java and whatever, it's just Node and app.js. If you have arguments, so if you have command line arguments, Node supports that, and it supports it the same way Java supports command line arguments, the same way Python supports command line arguments, pretty much the same way every programming language I've ever used supports command line arguments. So you use your keyword Node, which will invoke the Node application. It will feed it as the first argument, whatever the JavaScript file is, and then every argument thereafter is a command line argument. And so this is an example there. And believe it or not, we have access to all the command line arguments inside of our Node script, inside of our JavaScript app, inside of a process object. So there is a process object that is built in to the Node environment. One of the properties that this process object has is an argv, so argument values property. Inside the argument v array, we have a first element, which is the full path of the Node command. The second element is the full path of the file being executed. And then the third element and every element thereafter will be your command line arguments. And let's see here. I think I actually created a sample here. Let's go over here So first of all, let's see. I have Node. Let me see. I'm pretty sure it's got a version. So I am using version 15.12.0. Okay, so let's clear out of this. Okay, so what did I call it? Let me do ls. No, ls. Command line args. Okay, that's clear. Okay, so I'm gonna run this. Actually, let's see what this looks like first. Let me go ahead and cat this. So command line. So here I have just a script. Notice I'm using an imperative paradigm, which means it's just statements printed into a file, JavaScript statements. So here I'm going to access this process object. I'm going to access the argv array from the process object. For each of the elements, I will print the value and the index, right? I'm going to do, oh, look at this. We didn't even get to there, but guess what? Console.log is a thing. Surprise, surprise. It's a part of both Node and the browser. And we will see that there is a lot of carryover between the two. Not 100%, but things like console logging is going to be the same. Okay. So let's actually go and run this. I'm going to say, hey, Node. Okay, so Node, and then, yeah, this was command line args. So we're going to run this. Oh, I didn't give it any command line args. Well, we got to see what happens with the default ones. So remember, the first element is the path in which the Node application is running. And the second one is the path that the JavaScript application that's being fed into Node is. Okay, so now let's actually give it some, so Ted was here. Okay, so we'll give it 3 arguments, and there we go. We have the first, the second, and really all the user supplied ones would start at index 2 and go all the way down until the end of the array. Excellent. Okay, so in addition to being able to just go ahead and launch our JavaScript applications right from the terminal or from our Bash environment, we can go ahead and launch what's called a REPL console. So Java actually has this. I don't know, did they teach you how to use Java's JShell REPL inside the 1583, the 2120 classes? This has become standard to Java since Java 11. I think we're now on Java 14 or 15 now. It doesn't matter. If you've used Python, Python supports a REPL. A REPL is pretty much an interactive programming environment. It's a console. I mean, we've all used a REPL in this class because that's been the console within the browser. So just like we have an interactive environment where we can type in JavaScript expressions inside of the browser's console, we have that inside of Node as well. And we can launch that just by typing in Node on its own without having any, without supplying a file name. So if I do that, it launches me right into the Node REPL. Now, Python has something like this, and I'll prove it. So most of the time, oh, shoot, let me do a new window. So like, for instance, if I type in Python 3 here, oh no, I guess it helps to spell Python correctly. That also loads right into a REPL. And actually, let's see here. So I have, let's see if on this system I had set up my JShell. And JShell. And there we go. That's my JShell. That's my interpreter for Java, my interpreter for Python, my interpreter for JavaScript. So all languages pretty much doing very similar things, which is good because it makes it easy to pivot from one to the other. Okay, so let's talk a little bit about the REPL console. Let's first talk about what REPL stands for. If you're not familiar already, it stands for read, evaluate, print, and loop, and that's pretty much how you get interactive code. That is the cycle by which what is happening for us to be able to implement an interpreter. So whenever there are instructions that are there, they are read, then they are parsed and evaluated, and then the output is displayed or printed, and then it loops back to reading the next statement, evaluating and printing. Then loop to read, evaluate, print, loop. Hence the term REPL. Okay. So we already saw how to launch that, and if and then this behaves just like the browser's console. So I'm not going to spend too much time playing around in there. So obviously you could do JavaScript expressions, and it goes ahead and resolves those. You can declare variables the same way that you would inside the console as well, right? So you can now there's two different ways you can declare variables, and I believe this is true inside the browser as well. You don't have to use like the var, let, or const keyword. If you don't, it will not only assign the value into whatever variable that you're initializing or declaring, but it will also print out the value. So here's an example here. So if we do x is assigned 10, without var or const or let, then it will then also print out the value that you just assigned. If you decide to actually use the keyword like var, then it won't print out any return values. So that's the one distinction between doing that inside of the REPL. Okay, you can do multi-line expressions inside the REPL, and in order to do that, it actually just you use curly braces. So use curly braces to define a block of code, and as soon as you open up a curly brace, the REPL is smart enough to know that it's not the end of statement, so it will continue to go ahead and read until you get to the closing curly brace. Okay, simple enough. You have an underscore variable, which will go ahead and get you the last result. So let me show you what that looks like in practice. So let's say I say x is equal to 10. Okay, well, if I do the underscore, notice it gives me that last result then. So it's just an alias that will always recall the last thing that got processed, essentially. Okay, there's some interesting things. So one of the cool things about the browser's console was that we could inspect the state of all of our objects to see what methods they had, what functions they had, right? So this made seeing what was available in our runtime environment very easy, and it very insightful as well. It allowed you to learn things that were available to you that you might not have realized initially. And so that same kind of discoverability, that same ability to inspect what is available to you is available in Node as well. So if we enter like a JavaScript class like number, and then we type in the dot, and we use tab to autocomplete, and I'll show you this, it'll actually give us a listing. So let's say I have number, so number is like this class, and then I'm going to do dot. The dot operator typically obviously dereferences something from that object, but if I autocomplete, if I go ahead and hit tab, then what it will do is give me a full listing of everything that I could potentially dereference from this object. So it gives me the ability to do really deep investigation and inspection of data that is available to me. So again, these are good strategies to know to better learn the system as you're developing in it, because it allows you to see things that you have available without having to read tons and tons and tons of external documents. So if there's something that you know you're trying to do that relates in this instance to numbers, you can see very rapidly, well, what is available, and then you could do a deeper investigation on like what the parameters were or how you go ahead and utilize that. So again, like today's concepts are to show you not only what Node is, but try to use it in a way that'll make learning a little bit quicker and faster for you. We can also inspect the global object too. So recall in the browser, so I want to do another distinction here. In the browser, our global object was the window object. That is not the case here. We have a completely different global object inside of the Node environment. So, and you can actually inspect to see what's available here by just going to type in global, right? That's the name of our global object, doing period as if you're going to dereference, and then tab to autocomplete. And here you can see you have all these, and this really gives you an indication of what is the standard library. So every one of these properties that are defined inside of the global object is a standard library. So the FS is like your file system, HTTP is for like web server stuff, path is for file paths, URL is for being able to parse URLs. You have all of your event management stuff, such as like setting your timeout. You have your module support stuff, just utility stuff. Set interval is similar to what we did with set timeout. You should already be familiar with those. Query strings. So again, some of these are carryovers, like set timeout, set interval, and things like that. You might be familiar with. Others are going to be new, like the process object that we'll learn how to take advantage of over the next couple of lectures. Okay, so in terms of just utilizing the REPL for you to be able to kind of play around with building interactive code, let's talk about some keyboard shortcuts. So if you do Control-C, that terminates the current command. If you do Control-C twice, that exits you out of the REPL. If you hit Control-D, it will terminate the node REPL as well. So Control-C twice or Control-D. The up and down keys will let you see the history of what you've typed in. So here, let me show that. So up recalls things we've typed in, and down. So again, very similar to any other REPL if you've used a REPL before. So this is similar to the browser. And tab keys will go ahead and autocomplete or list current commands that are available to you. So in addition to these keyboard commands, there's also what are called dot commands, which are essentially ways of issuing instructions to the REPL itself. So if you type in, for instance, here, dot help, it will go ahead and give you all of your dot commands. Dot break, dot clear, dot editor, enters edit mode, dot exit will allow you to exit the REPL without a keyboard shortcut. Interesting enough are these two here that allows you to load a JS file into the REPL session. Or you can also take what's in memory of your REPL and save that to a file. So you do have a mechanism to load things into your interactive mode or to take the code you've been interacting with and export it into a file. Yep, and we can stop by just Control-C and Control-D or doing dot exit. Okay, so that's enough about the REPL. Again, the REPLs are nice for being able to give you an interactive environment so that you can kind of poke and prod at your code to check what the state is at any given time, or to import your code and be able to play around with it. So let's talk about our basic console outputting and inputting. Well, we already are familiar with how we can go ahead and display code into our console. We just do console.log. So I'm not going to spend too much time with that. There's other things we can do as well. We can do console.clear to clear the console. We could do console.trace to print a stack trace. Yeah, so the current, that's a good question. So this is what my current plans are for our initial intro to the backend. We're going to touch around the mechanisms that have Node implemented so that you have a good, strong understanding of how the Node interpreter works. Then next lecture, we will look at the Node package manager and do a deep dive into how NPM works. And then the next lecture, so that'll be next Tuesday, and then next Thursday, so 1 week from today, we will have a lecture on Express and using Express to build out a web server. So and in fact, likely your application, your full stack application will be built on the Express framework, and then Node will execute your Express application. So yeah, we will definitely be using Express in our stack, or at least I will teach Express. Whether you want to use Express or not is up to you. But right now, I'm trying to cover some of the concepts that, believe it or not, if you go and read a lot of tutorials, or if you go and watch a lot of other videos, do not really get covered in terms of Node. And I think that some of these concepts are pretty interesting in terms of like a computer science understanding of what's going to happen with our backend applications. And so, considering that at least everyone in this class has had at least a year and a half of academic programming experience, I figured it's worth at least the cost of one lecture to go into Node in a very kind of, I call this Node basics, but into a much more meaningful way in terms of what Node can provide to you as a developer environment, similar to like what a Python dev environment or what a Java dev environment might provide access to in terms of its base functionality. And at some point, I do want to go over some of the core Node modules as well, like the file system module, the HTTP module, and some of the other ones that will be useful to understand what's happening with those. Okay, so I don't want to spend too much time with the output because console.log. Okay, so we did console.log. You can print stack traces. You can clear the log. These are all like very good things. In fact, again, if you want to know exactly what you can do, I could just type in console, right, dot, and then hit tab, and I can see, oh yeah, these are all the different commands that I can have my console produce. Here's an interesting one though: the time and the time end and the time stamps are really good if you're trying to determine the efficiency or the runtime cost of your code. So that's a fun one that you can do. Let's see, did I have an example of that one? Oh yeah, I had an example of that one here. So you could do console.time, and then you could do console.timeEnd. And so that can help you track the passage of time. Okay. Let's see here. Oh, and then if you wanted to do console input, like if you were using this to design something comparable to a Java 1 application, like a dungeon game, that would be interesting, actually, if anyone wants to try to port the old text-based dungeon game to Node. You have a module that's part of the standard library that's called readline that allows you to create essentially an interface where you can define where your input and output streams are coming from. And here again, just like Java has a system class that gets automatically imported into all of your Java code bases, well, every Node script, every Node application has a process object, and that process object has a standard in and a standard out. So if you want to go ahead and grab what's coming in from standard in or standard out, you can create an interface from this readline module, and that will allow you to be able to grab user input in an application. And again, just to give you an example of this, let me actually exit out of the REPL now. Clear out all this nonsense. Alice, yeah, I have something called standard in. So let me go ahead and run that. So Node, and let's do standard in. And here I can send out a prompt. What do you think of Node? Yeah, it's pretty good. There we go. And there it just goes ahead and redisplays that message. And we could see if I go ahead and just cat that code that I'm running, it's pretty much what I just used inside of right here. Okay. Don't want to spend too much time on things like console in though, because we're not really going to be doing a whole lot of that building web applications, because our input's likely going to be coming from our HTTP protocol and not from like keyboard commands. Okay, so other things though that I definitely want to touch upon is I had mentioned earlier that our syntax for importing modules is different. So Instead of import, we use the require keyword. The require is actually a method, so it then gets passed in a string that has whatever the JavaScript label is, whatever the name of it is. Now notice there's a distinction between even the pathway string for what browsers use for import versus, oh, thank you. Package is an apt word as well. So we can import packages. So essentially it is a JS file. However, we don't have to append a .js with the common JS module system, whereas we do have to append the .js extension using the ES module system. So that is just a slight distinction that you can be mindful of, is that on browsers you have to indicate that is the JavaScript file, and it is implicitly understood on the back end using the common JS module system. You will get used to it though. This is just something that the more back end you will do, and the more front end you will do, you will get used to having to use imports on one end and requires on the other. It is super annoying that there's two different schemes, and I'm hoping that one side will unify towards the other. But as of now, that's just the way that this full stack development for us is going to work. Okay, and so for instance, the way that this might manifest itself is we can export a little bit differently as well. There is a module, and you probably saw this, I think. Let me go back into my interpreter. So go here, and let me do global dot tab. So where was that? No, what was I? What was I lost my train of thought. Oh yeah. So here, one of the things in our global namespace is module. So this is where all exports by default are loaded into. And there's other things in here, like notice undefined is a global object. So that's how it knows how everything is undefined. That's just like at the browser level too. But so when you export something, it will get loaded into this module package. And so when we want to, and the way we can load something into that module is as such. We access module from the global namespace, essentially. We access the property of module called exports, and then we can assign something from one of our scripts into this export, say, for instance, car, which is an object. Then in some other JavaScript file that we intend to run using Node, we can say, hey, we're going to require car. And so that will import from module exports the thing that has the label car. We could do it other ways too, right? We can do exports.car and then assign car. Or we could do exports.car when we're actually declaring our array. I mean, not our array, our object. So there's a number of ways that we can export things into our into the global export space. And this is just something that I feel you'll get much more comfortable with as we start doing these labs. And then we will import them using the requires keyword. Okay, so let's talk about some more of these underlining mechanisms. So I mentioned that Node is single-threaded. I mentioned that it's event-driven. So again, these are similar principles that guide the way that our JavaScript runtime environment works at the browser level. So let's talk about how this kind of functionally works with our JavaScript code as it's going to run on the server level, on our backend level. So essentially, the event loop is the most important aspect to understand about Node.js, because it explains how our code is asynchronous and how it has a non-blocking I/O implementation. And so again, as we mentioned before, it runs on a single thread. So there's just one thing that's happening at a time, which is super critical, that everything is asynchronous. So that limitation is actually helpful because it simplifies how you can implement your program. This is actually one reason why Node is so popular, is because it is a single threaded process. For those of you who have worked on anything related to concurrency, it is a nightmare oftentimes having to ensure you have thread safety in your application. And so that is not a concern that we worry about. And the reason for that is because of the way this event loop works inside of Node. So you just need to pay attention on how to write your code and avoid anything that could block the thread, like synchronous network calls or infinite loops. So in general, most browsers, there is a event loop for every browser tab. So browsers themselves are kind of single-threaded, but if you've ever looked at your the resources that, say, for instance, Chrome takes, and if you open up a lot of threads, you'll say that it takes a lot of resources, and that's because every thread in Chrome is its own process. And that's on purpose, right? They don't want the entire browser to crash if one particular tab has a JavaScript implementation that has like an infinite loop. So you could just kill that one process, or even Chrome will say, hey, this page is taking too long to load. Do you want us to kill it, or do you want to wait on it? And that's just because that's an enormous processing task that's happening in the background there. Okay, so blocking the event loop, any JavaScript code that takes too long to return back control to the event loop will block the execution of any JavaScript code in the page. And that means even blocking things like your user interface elements, which makes things like clicking lagging and things like that, which is it's not good. This is why we have this asynchronous model. So I'm assuming that everyone's familiar with a call stack. So the event loop does have a call stack, and it works the same way that a call stack works in any other programming language. So it's done just like a stack is, LIFO, right? Last in, first out. Okay. It is possible to queue functions, but I don't really care about that. We can have our message queue, and we can have our job queue. This is the big thing here. I should really add maybe an image to sell this. But with our job queue, it's essentially implemented using a promise-based system. So again, the entire reason why I want to go into the event loop on the browser side is because this is the same paradigm that our code is essentially managed on our Node side as well. So essentially, every time you have a function or a statement, it gets put into the event loop, and the event loop will go ahead and draw from it the statement that needs to go ahead and get executed. And then using an event emitter, you can also put things in there in addition to the things that are populated to your call stack. So you can emit events that get put into your event loop. But in addition to that, to prevent having to wait for large, complex processes to block the next event in your event loop, it's all promise-based. So it will execute, return back a promise object that is initially going to be pending, and then eventually it will be resolved or rejected. And based off of whether it's resolved or rejected, it could then trigger any set of cascading callback functions. So again, this same metaphor on how we talked about how we can do asynchronous programming on the browser side is actually how our code is implemented on the server side as well. The process object does have a next tick method, which allows us to go ahead and register things into the event loop to execute on the next tick of its processing. Okay, we can also set things to be immediate. We could set timeouts. We could set intervals. So again, all these things we can do with event-driven systems in the browser, pretty similar in our backend. We just don't have buttons, right? We're not pulling things from forms, but we could still set a timeout. We can still set intervals. All of your code is still going into essentially an event loop structure. And in fact, we even have a module that is in our global, it's our part of our standard library, which is an event module for managing events that get pushed into the event loop. And so in particular, there is a class that's called the event emitter class that allows us to define events and be able to emit them to the event system. And again, this is essentially the backbone that allows Node to be this single-threaded application, be able to manage multiple tasks without being blocked. Okay, so more concepts in terms of asynchronous JS, and I filled these slides up with a lot of depth, but I'm going to go through them quickly because we already covered a lot of these concepts. So again, asynchronous programming is not unique to JavaScript, right? It's something that all languages do. Like you can do these concepts in C or Java or C# or Python or any number of other languages. The way that we do it in JavaScript, though, is with a promise-based system. Yeah. So the first thing that we do is callbacks and promises. Notice that promises in Node are defined the same way that promises in the browser are defined. Very similar. So we create promises, exactly the same syntax. And in fact, we chain promises the same way that I showed in the browser slides. I can spend a lot of time re-explaining something I explained, I think, 2 lectures ago. And then here, we also have the async await means of defining asynchronous code. So again, the entire point of this is that we can write synchronous code in JavaScript. However, often is the case, you might have a task that you should consider asynchronous so that when it gets loaded into the event loop, it returns back a promise object and thereby does not block the next set of commands that have to get executed. And so for those that might have some time, such as any kind of network activity, you can just apply these async await keywords on there. And so the syntax here is going to be the same as it is for our browser. Excellent. I think I flipped these. Okay, so the last thing I kind of want to talk about in terms of the concepts of what's driving Node in terms of being like a OS level application and something that's not gardened and sandboxed inside the browser is that Node has streams. So streams are one of the fundamental concepts that power our application's ability to handle reading and writing files or network communications or any other kind of end-to-end information exchange in an efficient way. So streams are not a concept that's unique to Node. Again, these are all very common metaphors. So if you have taken a system programming concepts class, you've taken a OS class, likely a lot of these concepts that have been kind of briefly mentioned on what Node is doing, you should be familiar or at least seen these things before. But the takeaway is that these are all standard libraries that are available to us, and we will see how to take advantage of them probably next lecture. When we talk about NPM, we'll also talk about some of the more common Node modules as well. Anyway, let's see. So streams are not a concept unique to Node. Obviously, they're introduced with the Unix operating system decades ago, and it's something that we continue to use to this day. In 1583, you learn how to use your bash terminal and how to be able to, I think, even use like the pipe operator to be able to route data from one app and send it to another to be able to get processed. And so using streams, you could read data piece by piece. You can process its content without keeping it all in memory. Are you guys, so that's a quick question I might ask. Is everyone familiar with the concept of streams from system programming concepts? Is that something that gets covered in that class? And the only reason why I bring it up for a class that's dedicated to web applications is to understand how the web server is going to manage essentially large blocks of data. So get an understand of how data is essentially streaming in and streaming out, especially when the volume of it is quite big. Oh, excellent. Yeah, we don't need to know. Again, that's the big thing is we don't need to know these concepts in detail because we're going to be working at with most of this at an application layer, which means that these streams, these buffers, are something that's defined at it's a much lower level than we're going to be using in a practical way. But I think in many ways, it's good for you to know that it exists, right? So I really struggled whether I should add these slides or not, because I know it's not going to help for the most part in building full stack applications, but I think that there's a value in knowing a little bit of the mechanisms that drives how your backend server is getting in data or exporting data into your application. I think that's like the academic side of me. So, but the more practical side of me is just to mention it so you know it exists, but then to move on to something that's more practical. Anyway, so why streams? Streams basically provide two major advantages over using other data handling methods. They're memory efficient. You don't need to load large amount of data in memory before you're able to process it, and they're time efficient. It takes way less time to start processing data since you can start processing as soon as you have it rather than waiting until the whole data payload is available. And I'm sure you're mostly available with the concept of streams from streaming things off the internet. Like if you've gone onto YouTube and started to watch a video, you can start watching the beginning portion of a video before the entire video loads. And again, that is driven by this concept of what it means to stream, where you can get data in chunks and start doing something with it. So a typical example of reading files from a disk, and again, you can start reading file and the contents before the entire file is loaded into memory using input streams. You can start sending data before you might have even processed it all using output streams. Again, this is a concept we've seen before, even if we're unaware, using the system.out and system.in properties of Java, because that acts as the input streams and the output streams of Java's JVM system. Anyway, so a typical example of reading files from a disk might include this. So we will require the HTTP package here from the standard library. FS is the file system. Here we will define a server from the HTTP module, and we'll look at more of these standard libraries in a future lecture. We will create a server. The server requires a function that takes in requests and responses, because again, anything that relates to HTTP, it's a messaging protocol that's based off of having requests and responses. Inside the body of this function that this server will go ahead and have, the file system will read a file, and so it needs a path name to read that file. .get. And so inside the file system, we can have the file system create these streams for us. So again, in terms of what we need to know, we don't need to know the underlying mechanism. We just have to know how these method calls are operating. Anyway, so we can create in the file system this create read stream, and it will stream the contents of this data, and then we can then pipe it as our response. So this is just a practical example of how streams might manifest themselves. Call it function, I think. Oh yeah, you call a function using the dot notation. Similar to how we would do in browser side of things. And so we have as the pipe command. The pipe command should work on our file stream the same way that it would work at the from the bash terminal. Is everyone familiar with the pipe symbol in bash, where it allows you to essentially take one stream or the contents of one stream and sends it towards another application, or you could pipe data in and out of applications? Okay, good. So yeah, so streams, just like you would expect any kind of stream object to have, supports the ability to pipe the data from one application or from one source to some other target. And so this stream object, this stream concept, powers a lot of the APIs in Node. So standard in, standard out, standard error. For the file systems, create read stream. The file systems create write stream. The network's ability to connect, or HTTP's request objects, all depend on this concept of being able to stream data. And so there are 4 classes of streams. They have readable streams, they have writable streams, they have duplex streams, which is both readable and writable, and they have transform streams. The transform stream is similar to a duplex, but the output is a transform of its input. And then I just give basic examples. Again, I don't want to spend too much time. I just want to illustrate that the concept that drives how files are read into other applications, which is streams, is there is a stream object that's part of the standard library inside of Node by which we are doing the same thing. And it is an integral part that is part of the file system standard library and the HTTP request response. So just a little tidbit on what's happening there. And so when we talk about streams, we also talk about buffers, because when you get a stream, it's got to go in a bucket, and our buckets are buffers. And so buffers were introduced to help developers deal with binary data. They're typically linked with this concept of streams. So when a stream processor receives data faster than it can digest, it puts that data in a buffer. So just understand that with the underlying setup of Node, our standard in, our standard out are both streams, and we can define buffers if we want to. Buffer is a global, it's actually part of the standard library, and so we can actually declare our own buffers or create our own buffers if we need to. We can use buffers, we can access data in buffers very much like we would an array. We can get the length. In all practical purposes, a buffer can very much be treated a lot of times with the function calls like you would in an array. You can change the contents of a buffer, so you can write to it. You can copy buffers, you can slice buffers. Excellent. And I want to say the last part that I kind of want to just mention, and a more general component of Node, is on how we can do error handling. And so I really just want to relate error handling similar to you might have been taught it in Java. So it's exception based. Errors in Node are handled through exceptions. You can create an exception. An exception is created using the throw keyword. So you could throw some value. We can also create error objects. So if there is a particular error, you can just do throw new error. And so if you want to create a custom error, you can use the inheritance hierarchy. So you can create a custom error that extends an error, and then you invoke its constructor. So you can throw error objects. You can handle exceptions. So use the try catch block, and then inside the catch would be the error object or the exception object that gets passed into there. You can catch uncaught exceptions using, okay, so if we want to do that, what we have here is the process object. We can go ahead and invoke its own method and pass it just this example of an uncaught exception. And given some error, if the exception was not caught by the time it gets to the process object, we can do something like print it out and exit out of our script. So process also has exit. For the most part, you want to think of the process object in Node as exactly what the system object in Java is. So you kind of think of it as the root process that we can kind of rely on to exit a set of things or to manage system level concepts or properties. We can do exception handling in with promises. We could do that with by putting our catch statement as one of the chained expressions with our promise chaining. So yep, we can do error handling very easily that way. And we could also do error handling with async await. So we can await for something to happen, and then as a part of that block, right outside that block, we can go ahead and define a catch. So it's that we could do a try catch block. Inside the try is your await. And then if for any reason this fails, we can catch that error and then do something in response to that. And I think for the most part, I was able to cover everything as it relates to Node as its own runtime environment. So again, my motivation for today was to compare and contrast how Node is different from the browser and how it's similar. And so I didn't really have to go through any actual code, any coding in Node initially, because our code is the same. Like everything you've learned in the 14 or 13 other lectures we've done, I think we've done maybe 10 or 11 lectures related to JavaScript. That's all the same for the most part, except for the stuff that relates to the document object. Almost everything else is the same. So today I just wanted to take a deep dive into how Node works at the OS level. And so our next lecture on Tuesday, we're going to look at NPM, or what is short for the Node Package Manager, and how we can use that to get modules that are not part of the standard library into our Node applications. And then we'll probably also look at some of the standard library calls like the file system, like HTTP, some of the things that are worth knowing that you'll need to know to be able to start building your backend applications. And then we'll learn Express, and Express will make building web servers much, much easier. Is there any question about what we covered in today's lab for the most part? So I'm going to request that everybody go and install Node hopefully by tomorrow, because I'm going to release the new lab tomorrow afternoon. But it won't be due until the Friday after. So that's what, like April 9th. So you'll have until April 9th to do it. But please start getting that installation process done, since you'll have a new dev environment you'll have to be concerned about. And this next lab, you'll be actually using the HTTP module to build a web server in pure Node and NPM with no other frameworks. And then the lab after that will build a web server using Express, so you can see how much easier Express makes our lives. Express really expresses the concept of building web servers. Okay. Now just out of curiosity, okay, I'm done with the lecture, but to get some input, was this a good, insightful lecture in understanding what's happening with Node? Do people feel more comfortable about what it is we're going to do with Node with these principles that we covered? Excellent, and I'll get a better feel for it. Okay, good. Yeah, I'll get a better feel for it too as we continually go out. And again, it's always a tug of war to decide what to cut and what not to cut, especially when there's not in my opinion, a very strong textbook to go over into the course. So I don't want to get too into the academic, but I think there's a certain level that's worth knowing to give you a large scale picture of what's happening behind the scenes. So with that, I will leave today off. Everyone have a great weekend. Get your lab 7 turned in and prepare for lab 8, which will allow you to start getting into a state where you can start designing your own REST MPIs, your own REST endpoints.